Hi everyone, this is the QGIS Hydro Module number 4, Channel Network and Watershed Delineation. The objective of this module is to learn how to delineate channel network and watershed from a digital elevation model DEM using Saga GIS and Saga Processing Toolbox in QGIS. Successful completion of this module should enable the QGIS user to understand the DA 4-point method for assigning flow direction and grasp meaning and role of channel network threshold, and get channel order from a channel network, and lastly distinguish difference between watershed and sub-watershed in Saga GIS and QGIS. The data needed in this module are one raster DEM and two vector points data, which will be used as sub-watershed points for delineation processes. Actually, these data are provided on my GitHub repository, so you can access it with this address. So if you will go to my GitHub repository with this address, and then you can find this Hydro Modules folder. On here, you can click this number 4, Channel Network and Watershed Delineation. Then you can download this zip file. So click this download button. And then you can see this data can be downloaded for your folder. So after downloaded and unzipped the zip file, you can find this data, these data with one DEM and 2 points shape file as a vector data, okay? So you need this data. So actually I just created my working directory QGIS Hydro 04, and then I also made this data folder to hold this required data. Okay. So at this point, I will open the Saga GIS on this QGIS folder. So actually, this Saga GIS is one of packaging for the GIS QGIS desktop. So you can find this Saga GIS with the version of 2.3.2. So if you double click on this Saga GIS, so you can firstly find this selected startup project window. So you need to select this empty and click OK. Then you can open this Saga GIS platform with the blank map. On this Saga GIS platform, you need firstly open and load the grid data. So just File, Grid, and click this Load button, and then find your data on your data folder. So shift with all files, and then just you can click this DMPLJ-TIF file. So double click. After some seconds, on this data tab, you can find this DMPLJ file is just loaded. So double click. So you can open this DM file with this new canvas, new map canvas. So if you click this map tab, you can see these maps just opened on here. Okay. And also, if you are available, you can see this there, all the options on here for the settings. And then you can find the value range for the elevation for this data file. Okay. Now I will go to this geoprocessing tab to select this terrain analysis and then the pre-processing. Also, you can find this field sync Wang and Liu. So click this tool, and then you can find this field sync processing tool on here. On this tool, you can select grid system first, and then just select this one. And then for the DEM, you can select this 01 DEM PLJ file. And then leave all the required parameters with the default. And then just click OK. So now you can find these 3 more grid data just created with that tool. Okay. If you click this number 2 with the new map, so you can find this the no sync data with the DEM. Actually, the fill sync tool fills the sync in a grid. If cells with higher elevation surrounded any cell in a DEM, the flow gets trapped in that cell and cannot go downstream. The fill sync tool modifies the elevation values to eliminate this problem. The main function of this tool is to remove imperfections in the DEM to enable the flow to move downstream. With that, so if you can see this value range is changed with the DEM, the projected file. Yeah. First one, this range is just changed with these ranges, okay, with the fill sync tool. Then if you select the next grid data, the 03 flow directions and double click and open with again the new canvas. So then you can see this flow direction data on this the canvas. The tool we just used also holds the flow direction function that computes the flow direction for a given grid. The value in any given cell of the flow direction grid indicates the direction of the steepest descent from that cell to one of its neighboring cells, using the 8 direction per point D8 method. In the D8 method, the steepest descent for each cell is computed by looking at the slope between the target cell and its 8 neighbors. So after the process is completed, a flow direction grid like this image will be added to the data tab. After that, you will click this 04 watershed basins with a double click. With new canvas, you can see this watershed basins as well. As this tool processed the data, again this tool also have Bayesian functions. Then uses the flow direction grid to find all sets of connected cells that belongs to the same drainage basin and assigns a unique number to all the cells within that basin. So in this point, I will save this project with the save project as with my working directory, the name of QGIS04. QGIS 04, and then the extension would be .sprj file. Just save. Then also you can save all the modified data. So in this case, I will save all the data modified on this data folder. Save, and this one also on data folder. Then data folder, save, and then just OK. So now the project has been saved with the name of QGIS04.sprj file. So now I will use another geoprocessing tool, flow accumulation. The flow accumulation tool uses the flow direction grid to compute the accumulated number of cells that are draining to any particular cell in the DEM. So for that, you need to click this geoprocessing tab to find this terrain analysis and hydrology, and lastly find this flow accumulation tab. And from this tool, you need to select the flow accumulation top-down tool. So after open this tool, the window, you can select this grid system, and then as an elevation, you need to select this DEM no sync data. Okay. After that, change this flow accumulation unit with number of cells. And then also method, you need to select this deterministic 8 method. Okay. After that, click OK to run this tool. So after some seconds, you can find this newly created 05 flow accumulation data. So double click to open new map. So click OK. Then you can find this the flow accumulation data with the grid. So if you zoom in this one, you can find this accumulated cells on here with the flow. So it is similar with the liver network. Okay, so you can click this kind of the flow accumulation cell with this flow accumulation tool. Okay, so go back to the full extent with this button. Okay, the next geoprocessing job you need to do would be channel network. Because the flow accumulation gives the number of cells or area that drain to a particular cell, it can be used to define a channel network. It is assumed that a channel is formed when a certain area threshold drains to a point. This threshold can be defined by using the number of cells in the flow accumulation grid. If we assumed an area of 25 square kilometers as a threshold to create a channel, the number of cells corresponding to this threshold area is around 28,000. So for this job, go to Geoprocessing tab and go to Terrain Analysis and click Channels. And then you can find this channel network and then click to open this channel network tool. So very firstly, select this grid system with this one. So secondly, you need to select this DEM-PLJ no sync file. And then you need to select initiation grid with this flow accumulation. And then you need to insert the threshold with the 25 square kilometers with the cell numbers. So in this case, 27778 number of cell required to the 25 square kilometers around, okay? So you can easily calculate this kind of cell numbers with the grid cell size. Actually, for this DEM data grid cell size, just used 30 meter DEM, so you can calculate the area of the one cell, and then you can divide it by total areas of the 25 square kilometers, and then you can calculate these cell numbers, okay? After that, all leave the other parameters and then just click OK to run this tool. After 1 minute around, you can find this newly created 2 last data and 1 vector data. Okay, so double click to open this channel network. So you can see very similar with the flow accumulation data with the raster. So how about zoom? So you can find this channel network and then press go to the full extent, and then how about open this channel direction? Double click with the new map, and then you can see as well with the zoom. So this would be just to give channel direction, so you can find. So with the full extent. After that, how about open this shapefile channel network? So yes, you can find this the channel network with the shape file. So you can see these yellow lines, all the associated with the channels, stream channels. Okay, so we just created this kind of the channel network with that channel network tool. So now I will use the last geoprocessing tool for delineating watershed with the Upslope area interactive tool. Before that kind of job, I will open another data with file and shapefile and load. And then you can find this point shapefile from our raw data. Then I just opened this point shape data for that. After that, go to geoprocessing tab and go to terrain analysis and then hydrology tab, and then you can find this flow accumulation, and then lastly you can select this upslope area interactive tool, so click this one. After that, select this grid system as well as this DMPRJ no sync data for the elevation. After that, just select this method with the deterministic 8 method, and then leave all the default and then just press this OK button. After that, you can find this upslope area data, so you can open with the new map. After that, you could not see any other on this upslope area because we should made with the watershed delineation for this upslope area. For that, we need to open another channel network with this upslope area map, not the new map. You need to select this upslope area map. Just click OK. And then you can find this added channel network. After that, you need to add this point data as well for this upslope area map as well. So click OK. So now you can see this added two data for this upslope area. Okay. And lastly, you need another add this the DM no sync data for this upslope area as well. Okay. After that, if you go to this map tab, you can find this upslope area map with this one. So on here, you need to change the order of this layer. So this upslope area should go to move up all the to all the top layer. Okay. So after that, you need to change this transparency with 65%. Okay, so double click, and if you need to save changes, yes. So after that, this should be go down, move down all the bottom layer. Okay, after that, double click this one. So we just changed this transparency with 65% as well as the order of these layers. Okay. After that, you can clearly see with this top layer of upslope area with the bottoms of all the data, the channel network as well as the outlet points for the watershed. We should delineate, and then you can see as well the DEM data on here. After that, make zoom in with this area to select the river with the endpoint of the river network. In that case, you should select this action button. Okay. After that, so you can just assume this closed the area of this the river would be outlet point. So just click. And then you can see some differences on here. So for that, you can make full zoom. After that, you can see this upslope area is created as a watershed delineated area. So we just finished the delineation of the watershed. Okay. So after that, you need to go to this geoprocessing tab to uncheck this upslope area interactive tool. So just tap yes. So now I will save all the project related file with the save project. So and then you can see the unsaved the data as well. So checked, and you need to change the folder These the processed data with the data folder. So please change it with this data folder. All these data to save in that folder. Okay, and then just click OK. So now I all saved this project file. Okay. So in this video, I have made demonstrations for the first part of the first QGIS Hydro module with the channel network and watershed delineation in the Saga GIS platform. And I will continue the remaining jobs to generate sub-watershed and open these processed data in QGIS platform with the following video tutorial. Thank you for watching.